Welcome to my final presentations of the seminar course. It's about the paper report. My name is Harry, and I'm a first year student for master degrees in biomedical engineering. This is the paper I select for this paper report for the seminar. So the title is Optimization of Hyperglycemic Induction in Zebrafish and Evaluation of its blood glucose level and metabolite fingerprints treated with Psychotria malayana checkleaf extract. So the paper's impact factor is 4.2. It is Q1 journal, and the journal name is Molecules. And this is the outline for my paper report. So it's including the introduction, material method, the result, and conclusions. I want to talk about the introduction, and through the introduction I want to give you the background of the papers. This figure representing the abstract of the study. So this study aimed to establish an optimized protocol for inducing the type 1 diabetes in zebrafish, and through that evaluate the anti-diabetics activities of the Psychotria malayana leaf extract. And for the introduction of the papers, this paper using the adult zebrafish as an animal model to study the diabetics condition. So why we choosing the zebrafish? Because it's low cost, with fast testing, and more than 70% genetic similarity to human make the zebrafish very ideal for drug screening and other biomedical research. And it shares some key functions like the glucose metabolism and pancreatic activities with the mammal, which is very important when you study with the diabetes. And before that, there's no standard protocol for type 1 diabetes induction in zebrafish, and that will causing like inconsistent result, and this paper will focus on the protocol. So this paper will focus on building a reliable diabetics zebrafish model and test with the Psychotria malayana anti-diabetics potential. So but Psychotria malayana is used for diabetes in tropical medicines. It's like a modern scientific backing. And also this paper also compare the leaf extract compared to with insulin and other oral med, and they have some side effect. So this paper bring a new safer therapy in urgently needed. So this impact goal that the paper's aim is advance diabetes research by validating the P. malayana as a natural effective alternative for treating the diabetes patient. And next thing is the material method of the papers. First thing is the chemical using in the papers. So for the induction of the diabetic zebrafish, we're using two chemical. It's the STZ and alloxan. These two chemical we use for inducing the diabetes condition to the zebrafish. And there are some organic solvent, and to compare with the Psychotria malayana leaf extract, we're using the human insulin to compare the effect. And for the zebrafish maintenance, here this paper using the adult zebrafish with mixed sex and 3-month-old, and maintaining the 9-liter tanks at 28 degrees with pH 6.8 to 7.5, and the light cycle is 14 hours in light and 10 hours in dark. It's a standardized protocol for maintaining the zebrafish. And with the diet, they're using the high protein commercial food. So the aim of the study that using the STZ and alloxan is to develop a type 1 diabetic zebrafish model, and that will help us evaluate the anti-diabetics activities of the Psychotria malayana leaf extract. So the adult zebrafish were used for the experiment with a focus on the optimization of the induction protocol for consistent result. Like I mentioned before this paper, there's no standard protocol for induction the type 1 diabetes in zebrafish model. So for STZ, they're using various doses like 100, 300, 500, and 700 milligram per kilogram. And for alloxan, the same, but with 100, 200, 250, 300, and 350 milligram per kilogram. And after induction the zebrafish, so how do we know that the fish is now under the diabetes condition? Is through the blood glucose level measure. So to confirm the hyperglycemia induction. So the effectiveness of the diabetes induction method were assessed by comparing blood glucose level in treated zebrafish against the healthy control group. And after that, we have to compare the effects of the treatment. And to do that, we have to have the control group. And the control group will have healthy zebrafish injected with the citrate buffer, because we want to make sure that any effect is caused by the treatment, the chemical, not caused by the condition of the zebrafish. And for the diabetic group, is including the group that treated with glibenclamide or the insulin. And the blood glucose level we measure both treatment. And to compare with this traditional treatment with the chemical, we also treat the diabetic zebrafish with the plain extract. But before that, we have to preparation of the plain extract. So the source is a fresh leaf come from Indonesia. And after that, we do the instructions. So the dry barrette leaf boil in distilled water, filter, and then store. And after that, it's the administration to the zebrafish. And the force fed to the diabetic zebrafish at dose at 1, 2, or 3 and 3 gram per kilogram. And to know the mechanism and deeper in understanding of the treatment, we have to do some analytical technique like a GCMS or LCMS to the compound, to the plain extract. And another very important step for us to fully understanding the mechanism and how the compound work in treating the zebrafish, the diabetic zebrafish, is the histological study. And to do that, we have to harvesting the organ and fixation. So to harvest the organ, we have to sacrifice the zebrafish using the hypothermal shock. And then the fixation is the fish dry in the tissue papers and preserved in 10% formaldehyde in 24 hours. Internal organs, excluding the heart and kidneys, were harvested and fixed in for an additional 24 hours. And next is the tissue processing, is including the dehydration, the clearing, and bending, and the final step is the sectioning and H&E staining. And the next part of the presentation will be the result. Will show us about the induction of the diabetics and the comparison between the treatment. And for the induction of the type 1 diabetes using the HTZ, so to know that we have successfully inducing the diabetes condition to the zebrafish, we have to measure the blood glucose. And to do that, we have to fasting the fish at least 12 hours and then collect the blood to measure the blood glucose. And for using the SDZ, first this paper they follow the previous protocol from the previous study, and that study report that the SDZ with the 300 milligram per kilogram inducing the hyperglycemia in zebrafish with low mortality, but they injection of the SDZ multiple times, and they report is with the low mortality. But when this paper followed that protocol, the same doses, but the unexpected result happened. The mortality is very high, more than 80%, and with a significant drop up in blood glucose level over time. So because of that unexpected result, follow the previous protocol, they have to perform another experiment on the establishment of the type 1 diabetes zebrafish model. And to do that, the type 1 diabetic zebrafish model for testing plain extract for the anti-diabetic activities. So the STZ dose, they vary the STZ dose to study. So 100, 300, 500, and 700 milligram per kilogram were evaluated in figure right here. And to measure, we also do the measuring of the blood glucose of the zebrafish at 24 hours, analyzed after the single injection of the STZ with various doses. So the difference between their protocol with the previous protocol, they only inject the STZ one time. Previous they inject multiple times in different time point. And the result is no mortality occur, and 100 milligram per kilogram STZ show no significantly different from the healthy fish. But the higher dose is significantly different from the control, with no difference amongst the higher dose group like 300, 500, and 700. So because of that, we choose 300 milligram per kilogram was the lowest effectiveness doses for further optimization. And another optimization experiment to assess the effect of the 300 milligram per kilogram ATZ on the zebrafish fasting glucose at 24 hours, 48 hours, and 72 hours post-injection. So for the result, the ATZ significantly increased the glucose level at 24 hours without causing any mortality. But however, the glucose level dropped rapidly. So because of this, we are prompting further optimization using the another chemical, which is alloxan, to extend the hyperglycemia duration. And with the aim to extend the hyperglycemia duration, the alloxan we choose to test on the zebrafish to induction of the type 1 diabetes. So for that, we also do the fasting blood glucose level measure and various alloxan doses from 100 to 300 milligram per kilogram were tested for their effect on the fasting blood glucose. And the result is the dose of 200 and 250 and 300 milligram per kilogram significantly increased the glucose level at 24-hour post-injection. And at 48 hours, 300 milligram per kilogram alloxan maintaining the evaluate glucose level compared to the healthy fish. So, and about the mortality rate were 0% for the doses lower than 250 milligram per kilogram. And when we're using the doses 300 milligram per kilogram, it's 10% mortality, and it's 70% for 350 milligram per kilogram. And this also making the 300 milligram per kilogram is the optimal doses, and because it can extend the duration of the hyperglycemia, and also the mortality is very low, acceptable rate. And these doses were used to evaluate the hyperglycemia over 8 days. And to confirm the effectiveness of the alloxan when induction of the type 1 diabetes in the zebrafish, here is the fasting blood glucose level in the zebrafish analyzed after injection of the 300 milligram per kilogram doses for 8 days. And the blood glucose level were significantly higher in most of the alloxan treated zebrafish than in the healthy fish, between 24 hours and 168 hours, which is 7 days, after injection of the 300 milligram per kilogram doses. And the mortality of the doses is, which is still 10%, and very still acceptable. So after they established the protocol for induction of the type 1 diabetes in the zebrafish model, they studied the effect of the glibenclamide and insulin as a positive control on the fasting blood glucose level of the diabetic zebrafish. So this figure first using the glibenclamide doses of the 1.5 milligram per kilogram, and both drugs were injected to evaluate their capability to reduce the fasting blood glucose level of the diabetic zebrafish. As you can observe in the figure, the result through the figure, we can conclude that when treating with the glibenclamide with the doses 1.5 milligram per kilogram was not effective in reducing the fasting blood glucose level of the diabetic zebrafish. But there is so no mortality in the glibenclamide group, and the diabetes have 10% of the mortality rate. And the same with the glibenclamide is using the insulin as a positive control on the fasting blood glucose level of the diabetic zebrafish model. The doses using for the insulin is 1 U per kilogram, but very different from the glibenclamide effectiveness. The insulin does effectively normalize the blood glucose 24 hours after the alloxan injection. So since no significantly different was observed in the glucose level between the diabetics group and the healthy group, the mortality rate of the treated zebrafish was 0%, indicating an improvement compared to the diabetic group with the mortality rate of 10% due to the alloxan injection. right after we got the effect result from the positive control, we want to bring out our main character. It's the evaluation of the anti-diabetics activities of the Psychotria malayana leaf on the alloxan-induced type 1 diabetes zebrafish. So different doses of the aqueous extract of the Psychotria malayana leaf is 1, 2, and 3 gram per kilogram per test on the alloxan-induced type 1 diabetics in zebrafish model. And at 48 hours post-alloxan and 24-hour post-treatment, the doses of 1 and 3 gram per kilogram of the leaf extracts normalize the glucose level, while the 2 gram per kilogram doses remain significantly different from the healthy group. And like I mentioned in the previous result, the insulin, which is the positive control, also normalize the glucose level, and no mortality occur in the healthy or treated group, while the diabetic group had a 10% mortality, like I mentioned all of the result before. So this is the GCMS analysis of the Psychotria malayana leaf extract, because we want to identify the compound which play role in helping the reducing of the blood glucose level. So this is the list of 29 compounds identified in the aqueous extract of the Psychotria malayana leaf using the GCMS, and with similarity in this over 90% in the NYST 14 database, and sugar like sucrose, fructose, and other dominate over 50% of the total peak area. The minor compound including the phytosterol, sugar alcohol, free fatty acid, xylitol, phenolics, and alkaloid. And this is the LCMS based fingerprint of the zebrafish serum. So this fingerprint were used to identify the serum metabolite in zebrafish and assess the anti-diabetics effect of the Psychotria malayana leaf extract, and evaluating the dose-dependent change and underlying the biochemical pathway. The serum from zebrafish from 4 groups: the healthy, the diabetics, the insulin-treated, and the plant extract treated, were analyzed using this LCMS, and BLSDA showed that 45.6 variation explained, that we're indicating the acceptable predictability. Validation confirmed of the model reliability with the R2 and Q2 intercept with the acceptable range. And the final step for a deeper understanding of the effect of the chemical when inducing the type 1 diabetes, or the treatment when reducing the blood glucose level, is the histological examination. And this histological examination aims to assess the structural change in the pancreas of the zebrafish following the diabetes induction using the ATZ or alloxan. So the biofilm section of the pancreatic isolate were stained with hematocillin and iosine. So the healthy zebrafish show a normal isolate structure in figure A and B, which is A is 40x magnification, B is 100 magnification, so our normal histology of the pancreas with the high cellularity of the Langerhans, and this indicating the normal isolate structure. And with the group in the C and D, which is the alloxan ejected group section, showing the high reduction of the endocrine isolate cellularity as indicated by arrow in the alloxan group. And this means that diabetics and treated fish display altered isolate structure and cell loss. And that was for the healthy and the diabetic zebrafish group, and this for the treated group, which is A and B for insulin treated zebrafish, and C and D is for the plant extract. And both of this showed us the isolates show the high reduction of the endocrine isolate cellularity as indicated by the arrow, which means this is shown by the different isolate structure compared to the healthy zebrafish. It's quite similar to the diabetic zebrafish, and there was a considerable loss of cells inside the isolate. And for the next histological examination, which is the analysis of the biofilm embedded section of the zebrafish liver was performed using the hematoxylin and eosin staining of the section obtained from the healthy and the diabetic zebrafish. So in the healthy zebrafish, the section showed that the normal hepatocyte structure, and expected in the diabetic zebrafish, the section showed that the normal structure of the hepatocyte compared to the control, which means there's no significantly difference between the healthy zebrafish and the diabetic zebrafish. And the same examination, but here we got the result for the insulin-treated zebrafish and the plant extract-treated zebrafish using the same dose as previous examination, which is 3 gram per kilogram. And for the insulin-treated zebrafish, we finally get the significantly different compared to other group, which is we can see the appear of the nodule of the damaged hepatocyte are indicated by the arrow, and we can conclude that all the hepatocyte structure in the old zebrafish were normal, except for those in the insulin-treated zebrafish, which appear at the nodule of the damaged hepatocyte separated by the fibrate band. And to summarize of the method, the material, and the result in the research, we got the conclusion over here. So the type 1 diabetics model, this paper successfully developed a reliable zebrafish model using the ATZ or alloxan to induce the type 1 diabetes. And the optimal dosage is 300 mg per kilogram for both of the ATZ and the alloxan, as effective in inducing the hyperglycemia in the minimal mortality. And the Psychotria malayana efficiency. So aqueous extract reduced the blood glucose significantly, with 3 gram per kilogram being the most effective dose. We call that the optimal doses. And the bioactive compound using the LCMS identified the phytosterol, the sugar alcohol, and the phenolics contributing in the therapeutic effect. And for the histological evidence, the pancreatic isolates show that reduced signs and degeneration, confirming the successful of the diabetes induction. And for further research, now we finally got the effectiveness of the Psychotria malayana potential as a natural, safer anti-diabetic therapy. And for the zebrafish utility, the reinforced zebrafish as a valuable preclinical model for anti-diabetics compound screening. Clinical relevance is advanced diabetic treatment develop and underscore the role of the natural product in chronic disease management. The reason why I select this paper to present to all of you is because right now I'm currently working also the zebrafish model and also the diabetics as the diabetics model using some chemical to inducing the type 1 diabetics model. And from this paper helped me got the background knowledge to conduct my own experiment. And finally, thank you for listening to my presentation. Thank you, Professor Kerr and fellowship classmate. If you have any question, please give me the question on iLearning, and through that I can gain more knowledge for my own experiment in the future. Thank you so much.